So today I want to show you how to calibrate the Langer probe P500, and this calibration instruction is exactly the same for the P501 and also for the P503, with the difference that the P503, the ampere meter is only up to 1 gigahertz, and for the P501 it's up to 3 gigahertz. Here you see this probe, and I first want to show you which parts you need for this calibration. And so the most important thing is this calibration standard. This is called now DLM A01. In addition to this, you need this ground adapter, GND A02, and the big ground plane GND A25. Of course, you also need a probe P500, and in addition a terminating resistor. This is a 50 ohm terminator. And external devices for measurement, you need a vector network analyzer I have here, and or an alternative to the network analyzer, you can also use a spectrum analyzer with a tracking generator up to 3 gigahertz. So, some short information about the P500. So this is a high-frequency power injection probe, and you connect a high-frequency input here with the SMA connector, and then you have a pin contact. So this then leads to the pin contact in the front and goes directly into the circuit. What is also part of this probe is that you can, at this point of pin contact, you can measure also the voltage and also the current that goes into the pin. So this means we need to do 3 calibrations in total today. The first one is for the transmission curve from the SMA connector to the pin contact. And the 2 other calibrations we will do is for the ampere meter and for the voltmeter. The first thing we do is we take this GND A02 and put the feature standard, the DLM A01, inside. At the bottom we have then a screw, and we can make it tight. This whole thing we can now put in the GND 25. Like this. And this is the setup for the ground plane. To start measurements, we will start, of course, with the transmission curve of the P500. And this means we need to connect SMB to the calibration standard on the bottom. This is a SMA wire, SMA connector. So when it's tight enough, we will turn it around again. And now we have the probe, and we place it on the ground plane, like this. And for finishing the setup, we will now connect port 1 of the network analyzer to the SMA input of the probe. Just 1 second. Of course, we also need to power the probe. So we connect the supply voltage, 12 volt, from the back. And now I place it directly on the pin contact, the contact area of the calibration standard DLM A01. And to be sure that I'm really connected, I will now press the contact detection of the probe. And when the LED is on, this means I have a contact to the calibration standard. So what we do then is we take a look at our network analyzer, who is taking the scattering parameters. And for us important is now the scattering parameter S21. I will now load this scattering parameter into my chip scan software. And you can also already see the green line, and it looks nearly perfect. It's around 0 dB. And I'm confident with this, and I will now take this curve and save it as the transmission. Like this. So this was everything for the calibration of the transmission curve. Of course, we will in the end compare this curve to the one from the factory calibration, but we will now go on and take a look at the calibration of the ampere meter. For this, I disconnect the supply of the probe again. I remove the probe from the ground plane. Now I also remove the SMA cable from the calibration hardware, from the DLM A01. What is important now, that when calibrating the ampere meter and the voltmeter of the P500, we need to put the 50 ohm terminating resistor on the bottom of the feed-through standard here. This is done. I will place the probe again. Now for the ampere meter and the voltmeter, we don't have a SMA connector, we have a SMB connector. So I will now place this adapter here. So you can also use a different cable, but then if you use a different cable, then be sure that you normalize the vector network analyzer again after changing this wire to an SMB wire. Because I made the normalization in the beginning with exactly this cables, and if I change now something, this will also change my results. Okay, now I will connect the supply again and check with the contact detection if I'm connected. And this looks good. So now I'll take again a look into the curves of my network analyzer. And here we see the green line is the curve for the ampere meter. I will take this curve, name it M meter, and change the color to green, for example. So the last thing we need to do now for the calibration is calibration of the voltmeter. And now, in comparison to the calibration of the ampere meter, we just need to change the SMB connector from the ampere meter output to the voltmeter output, like this. Again, connect the supply of the probe and check if we are connected to the pin. And the LED is on, so I'm connected. And now I will again take a look into my the curves of my network analyzer. And here you see again in green, this is the curve of the voltmeter, and this is nearly exactly on minus 40 dB. And this looks good. This is exactly what I want, and I will now take it and save it as voltmeter. Make it blue, for example. So now I have in total 3 curves. One around 0 dB, one for the ampere meter that is going up a little bit, around minus 30 dB, and one for the voltmeter on minus 40 dB. And what I can do now is I will export this. As and now I will open this file that is delivered with every probe, this characteristic file. And now I can insert the values from the CSV I generated into here, and then compare the diagrams to the one I have here. So this is for the ampere meter. This looks the same like in our like the curve we took now. This is the calibration curve for the transmission, and this is around 0 dBm, exactly like the one we took a few minutes ago. And for the voltmeter, it's on minus 40 dB. So it looks nearly the same like the one we took here. So of course you then need to do a comparison if the curves, so the curves are not allowed to differ more than plus minus 5% to be valid. And if it differs more than plus minus 5%, then the probe is not working and needs to be repaired or replaced. And yeah, this is everything for the calibration. Then I will thank you for listening, and yeah, see you the next time.